Hello and welcome to this Mobilize webinar on how to build a Kubernetes platform. My name is Gareth Davis and I'm a Cloud Solutions Architect here at Mobilize. And the kind of aims of this webinar are to try and get across what considerations you need to make when building Kubernetes platforms, what components are involved, and some of the common misconceptions or assumptions when setting out to build a Kubernetes platform. So without further ado, let's get into it. So if you're coming from a background of traditional infrastructure, you may not have heard of Kubernetes or containers. So let's cover this off quickly before we get into the nuts and bolts of it. So what is Kubernetes? It's an orchestration platform for containers. I guess the next question then is, well, what are containers? So traditionally, you would have applications installed on virtual machines, and you would package up those virtual machines onto a piece of tin, a piece of physical infrastructure or hardware, server hardware. And that worked fine for a time. But then people realized that when you're installing these applications on these large virtual machines, there's a lot of wasted space there in terms of resourcing. So in terms of CPU, memory, a lot of it is taken up by the actual operating system that you're installing your application on. So for example, if you install a small application on a Windows virtual machine and you want to segregate out your applications so that you have one application installed per Windows virtual machine, you might end up with something like 10 Windows virtual machines on your physical server. And so you can quickly see that you have 10 OSs taking up a lot of resources from the physical server, whilst you're only getting away with perhaps running 10 of your applications. So what containers do is provide a kind of really stripped down environment to run your applications in. So using some clever technology, which we won't get into at this point, they allow you to package up your application into stripped down OS containers, essentially letting you run where perhaps before you could only run 10 virtual machines on a server. You'd be able to run hundreds or thousands of containers on that same server. And so why would we need Kubernetes to kind of manage that? Well, if you imagine you're running hundreds or thousands of containers on a server, you have to think about high availability. So how many instances of that same application do you want to run in case one goes down? How do you deploy new versions of your application to these containers? How do you manage the general day-to-day administration of things like disk storage, usage, putting in place security procedures, and that kind of thing. So it quite quickly becomes a large problem. So that's where Kubernetes comes in. So originally developed by Google way back when, it is now a CNCF project, a Cloud Native Computing Foundation project. So it's a piece of open source software. And it's been taken on by the major cloud providers. So, cloud providers like AWS, GCP, and Azure now have their own Kubernetes managed service. So what this means is that in a traditional environment, if you wanted to install Kubernetes, you would have to do it yourself. It's quite time consuming, it's quite complex, and a lot of your day-to-day time spent as an infrastructure engineer would be on managing this Kubernetes cluster instead of trying to speed up your delivery team's rate of delivery or assist them in building things like CICD pipelines. So what the cloud providers have done is provide these managed services so that the focus can return to helping your delivery teams accelerate their delivery. So moving on, why would you build a containerized platform? So why go through all of the hardship, I guess, into re-platforming your existing applications, rehosting to the cloud, and changing the whole culture of how your organization approaches applications, workloads, and deployments? Well, there are some really big benefits. I guess the first kind of one that springs to mind is this idea of a common platform. So I think all organizations, will have been through the pain of maybe having these disparate systems where you have, 5 to 10 different systems supported by different teams with different methods on how to deploy to these environments, different operational procedures. If you're coming from one team to the next, you need to retrain on how that other team uses their tooling and architecture. And so, there's a lot of overhead in managing that kind of environment. So moving towards a containerized platform, you can quickly introduce standards and kind of cloud native architecture to bring all of these services together so that you have this one common platform where it doesn't matter what OS your application needs to run in, or what libraries it needs, or how it's configured. You can package it up and deploy it the same as you would any other application on this common platform. So that really is a big selling point. The next point is better development. So with containers, you can run your workloads in the cloud just the same as you can run them locally on your development laptop. So there is no more of the complaints that you might have seen in the past where you've built your application, you've tested it on your laptop, you've pushed it out to a production environment, and it doesn't work. And you have that, old age adage of, well, it worked on my laptop fine. Well, what containers do is abstract a lot of the dependencies that are built into your application from the OS, away from the OS. So, instead of having an application that runs fine on your laptop, which depends on perhaps some libraries that are installed on your OS that aren't present in production, causing that problem, you can package it up into a container. And so the container has all of those dependencies built into it. So when you do spin it up in new environments, it is always going to run just the same across cloud and your local devices. So it really is a great tool for new development practices and getting your team to work faster and quicker, because you don't run into as many of those problems. Portability is another big aspect of Kubernetes. So as I mentioned, the big cloud providers have a managed service for Kubernetes. But because Kubernetes is now an open source standard, you can shift your platform relatively easily from one provider to another. So you're not getting into this vendor lock-in that you might have with cloud proprietary services, such as some of the serverless compute services. The next aspect is high automation. So Kubernetes lends itself to being, really open to being highly automated. So you can really focus in on your CICD pipelines and get to the point where you have builds, tests, security tests, and deployments all being kicked off simply by checking in code to your repository and using triggers to push that code out. So it really does lend itself well to automation. And finally is the really interesting aspect of cost efficiency. So, whereas before you might have had these disparate systems spread across different servers, you can now package all of that into one or two servers, because you can cram all of these containers right down into individual boxes, so that you can make the most of each individual box's CPU, RAM, and other resources. So the idea is to run these kind of Kubernetes clusters hot, so that you can pack as much into one instance before you skip over into the next instance and start scheduling workloads there as well. So you can really drive down costs with this common platform. Okay, so let's take a look at our architecture. So what we have deployed here is the Elastic Kubernetes service on AWS. As I've mentioned, there are similar services on other cloud providers. However, we'll be focusing on AWS for this webinar. So you might think, well, we've deployed the service, that's it, job done. But there's a lot more to it than that. As Kelsey Hightower once said, he's a advocate in the Kubernetes community for better practices. He said Kubernetes is a platform for building platforms. It's a better place to start, not the end game. And this rings very true. So, it is a great place to start. It's got some great tooling built in and methods and processes. But if you're serious about building, a standardized, containerized platform to host your enterprise applications on, then you're going to need a lot more help from other services deployed around the Kubernetes cluster. So what might those be? Well, we might want to look at things like AWS best practices. So how do we lay out our account structure so that we can segregate workloads? How do we ensure that MFA is enabled so when users log into AWS and access our platform, they're using multi-factor authentication? So things like that. How do we provision our AWS resources in a highly automated fashion? So how do we spin up CICD infrastructure pipelines so that we can automatically deploy AWS resources? The same goes for our applications or workloads. How can we make sure that when we check in code, it's automatically built, tested, and then deployed, with a single click? And how can we make sure that that is done day in, day out, reliably, helping developers accelerate their delivery? Testing. How can we migrate a lot of the effort in manually testing workloads into the CI/CD pipeline? Even moving automated testing into the CI/CD pipeline so that we don't have to have processes for manually kicking off automated tests. We can move that into the pipeline so that it all happens at build time. Logging. How do we ensure that we have a centralized logging solution? So, we don't want individual users logging onto the Kubernetes cluster to check log files of applications because, that damages our security posture and means that we have to hand out a lot more access to these clusters. So how can we get ship logs off those clusters into a centralized location? Monitoring and alerting. How do we ensure our application is always running, always up, with high availability and resiliency? Well, we do that through monitoring a lot of different metrics and creating real-time alerts off those metrics that can feed into things like service desks or Slack or email. How do we bake in security best practices? So, we need to do this at various different levels throughout our platform. So, for example, at the AWS level, we need to do things like, as we spoke about, MFA. At the EC2 or infrastructure level, we need to look at things like security groups, keys, encrypted volumes, that kind of thing. And then how do we do it at the Kubernetes level? Well, we need to make sure that we use things like network security policies and resource and usage limits. So, there's quite a lot to look at in terms of security and making sure that we're building a platform that uses defense in depth. And then finally, cost control. So if we sold the dream to our stakeholders of, a unified platform that's going to make our lives a lot easier, how do we ensure that we keep costs down when running this platform? By using things like spot instance technology or ensuring that, containers are scheduled correctly and we're making the most of our virtual machine layer. Well, let's take a look first at our AWS architecture. So this is just an example of what we might look at doing in our common platform on the AWS cloud provider. We might look at doing things like segregating workloads into different accounts. So we have, for example, a management account, which houses our Git and other tooling. We have an audit account, which looks after our audit trails from all of the other accounts and limits access to that account to specified users like security engineers, for example. We have our non-production account, which segregates workloads from the production account. And what this means is that we can implement service limits across these accounts through AWS. We can control access centrally to these accounts. So, for example, do we want developers being able to access the production account, for example? We can use role-based access control to limit that. And then setting up things like guardrails and landing zones. So when we create these new AWS accounts, can we bake in some best practices and security features so that each time we create an account, we don't have to manually go around turning on features and setting up configuration. We can bake that in to each new account's creation. And that fills into the organizational setup. So how can we manage these accounts centrally and ensure that we are using or enforcing best practices? Finally, it simplifies billing a lot. So standard practice is to tag as many of your resources as possible so that you can use things like billing cost explorers to analyze your billing. But if you're being a little lazy, then you can just segregate your workloads by accounts, and you can look at the billing specifically for that account. So that's our AWS best practices. Now let's look at our CI/CD pipelines. So this is perhaps how our architecture might look like for our CI/CD environment. We have a centralized CI server with some worker instances that perform the tasks, including things like builds and deployments, that then get pushed out to our Kubernetes servers. So why have this central CI server? So what we want to move away from is a pattern of having developers building, testing, and deploying their applications from laptops or other devices. We want to move to a centralized solution where we can take back control of how builds are built, tested, and deployed. Why? Well, as we touched on earlier, there's a good chance if developers are building locally that they're introducing unknown artifacts into their builds. For example, if they've installed plugins or different library versions on their laptops, these will get included in builds and get pushed out to production. It also means that you're able to control the release of deployments from a central location. And it means that we can harden our Kubernetes environments to only receive traffic from this management VPC. So it's all about security and governance in terms of how we control our builds so that they are reliable and repeatable, and how we secure our deployments. So moving on to the pipelines. A pipeline is all about how we go from taking a build, building it, testing it, and moving it into a Kubernetes environment. And there's a lot you can fit into a pipeline, which we'll cover here. So, you might start with something like your agile tooling, so your collaboration tooling such as Jira, which you can then hook into your pipeline. So if you complete a task in Jira, that might kick off a step in your CI server. More often than not, though, it begins from your kind of Git process. So, for example, when we check in code to a particular branch, we might want to start our CI/CD pipeline to create a build of whatever's checked in on that branch. So we can automate that so that our CI server is looking for, triggers or hooks. When code is checked in, it automatically kicks off a build. We can then perform some DevSecOps. So we can build security into our CI/CD pipeline so that we're not waiting until we get to the actual environment it's deployed in before we perform security testing. So we can perform automated security testing as well as functional and performance testing of our applications within these pipelines. And what we can do then is provide kind of gated deployments. So once it's passed all of these checks, we can have a gated check to make sure that we only deploy, for example, up to our test environment. We don't automatically deploy to our production environment. That next step involves some kind of human interaction to approve the deployment and push it out to production. Furthermore, we can kind of create pipelines not just for deployments, but for operations as code. So, I think we want to move away from developers or support users logging on to production environments to run scripts or query services. So let's build those operations into our pipelines so that, a developer or support user can just perform a one-click function on our CI server, which kicks off that operation and gets the results back. And finally, it's all about standardizing all of these deployment mechanisms so that there really is only one way to deploy to these environments. And that's using our CICD pipelines to deploy to Kubernetes. And that means that we can kind of consolidate our deployment mechanisms so that we don't have to have, 3 or 4 different ways of doing it, reducing the need for different teams to learn different tooling and methods, and also making it easier to onboard new team members to the organization. So it's all about kind of letting the organization focus on developing services and features rather than worrying about infrastructure and tying up teams' focus and effort on things like builds and deployments. So let's look next at logging. So as I mentioned before, we don't want people logging on to servers to check log files. We want to actually push those logs to a central location. So what we can do is in Kubernetes, we can install agents which grab logs and push them into things like AWS CloudWatch, or the example shown here is an Elastic platform. So by centralizing these logging components, we can make it a lot easier for incidents to be resolved. If you're being called out at 3 a.m, having all the logs in a central place, only having to log into one environment rather than having, 10 different IP addresses to SSH2 to follow logs from one server to the next makes it a lot simpler. We can also do things like create dashboards and let support users quickly and easily identify problems with our platform. And we can increase observability. So it's not all about logging. A lot of it as well is about telemetry. So we can get a lot of telemetry from our Kubernetes platform, things like how well an individual service is performing, its response times, its CPU usage, that kind of thing. So moving on to monitoring and alerting, as I've mentioned previously, we can monitor our workloads at various different levels. This diagram shows a CloudWatch Insights level. So that lets us look at our cluster and easily see how well it's performing, things like disk utilization, how many nodes are running within the cluster. And what we can do is for each of these individual metrics here, we can create an alarm based on thresholds. So for example, if our CPU utilization goes above 90%, we can alarm on that quite easily. We can also introduce things like anomaly detection so that we don't have to define these thresholds up front. We can ask AWS to monitor the metric, look over its history over the previous 2 weeks, and if anything out of the ordinary happens, send us an alert. So, we can move away from having to define upfront these thresholds and let AWS worry about that for us. Moving on to security practices. it's often the highest priority of an organization is to ensure that their platform is secure. So how do we do that? Well, it is a lengthy process, and it's something that should be done from the start, so that we're baking these security practices into our solutions. You have to look at the solution as a whole. So in a common platform that we've been looking at, there are perhaps three different kind of levels that we would look at. The primary level being the AWS platform itself, the secondary level being the EC2 infrastructure, and then the third level, the Kubernetes platform. So there are various different technologies and methods you can introduce to secure your platform. At the AWS level, for example, we might introduce things like multi-factor authentication, so that when people log into AWS, they have to have their MFA code with them. At the EC2 level, we would implement EC2 security groups. We might remove the SSH access and use things like AWS's Systems Manager, so that we can SSH into the boxes through the AWS console rather than having to manage users and keys for EC2 instances. At the Kubernetes level, we would look at things like pod security policies, network security policies, resource and usage limits, just to ensure our cluster is running securely. So all of these things, add up to making your platform as secure as possible. We've actually covered some of this in the blog. You can see at the bottom of the screen, but it boils down to performing a kind of well-architected review of your solution and ensuring that you are covering as many angles as possible. Finally, cost control. So how do we stop our costs from spiraling out of control? One method is to use things like spot instances. So AWS spot instances let you save up to 70% of your EC2 costs by using these spot instances. Now, we primarily see spot instances used in development and test environments, but possibly not so much in production environments. The reason for this is that spot instances can be reclaimed by AWS with only a 2-minute warning. So you may only have a 2-minute warning before your server is taken down and you have to replace it with a new server. But this works well with Kubernetes because your workloads deployed to Kubernetes should be stateless and should be built for fault tolerance. So when an instance is taken away and a new one comes up, your workload should recover and hopefully act as if nothing had happened in the background. So that works very well for non-production environments. Another thing we might look at are things like budget controls within the cloud provider's platform itself. So within AWS, that means using things like AWS budgets or even savings plans to reduce costs. We can put alerts on certain billing items to make sure that we're not spending too much. So I hope that's given you a kind of brief overview of how you might build a Kubernetes platform. As I've mentioned, it's not just the Kubernetes service itself in the middle, but you have to build all of these surrounding components to make sure that you have a robust, reliable platform that people can depend on to accurately and reliably deploy their code to their production environments. So, in summary, what are the objectives of building a containerized platform on a technology such as Kubernetes? Well, it's getting a common platform. It's ensuring that we can build and deploy applications in a standard way, and have people trained in that standard way, so that we're not having to cross-train people on many different services and systems. It's about better development. It's about utilizing containers so that we can run them locally as if they were production environments themselves. It's about using Kubernetes to perform rolling deployments. So, there's no more waiting for out of business hours to deploy our applications. We can use Kubernetes to automatically use rolling deployments and deploy our workloads with zero downtime during the day. It's about building kind of complex and mature CI/CD pipelines, including things like security and performance testing, to make sure that our application or workload has kind of been thoroughly vetted before it even reaches, one of our later test environments, and moving a lot of that work into automation. And finally, it's about reducing cost and technical debt. So by consolidating, all of our workloads into a standardized platform, we can greatly reduce the technical debt that might be lying around an organization. And we can also kind of focus on reducing that cost as well by not having so many disparate systems. So I hope that's been interesting and given you a bit of an insight into how you might go about building a Kubernetes platform and the components involved. Please head over to our website to look at some of the blogs that we've written on things like Kubernetes security, spot instances, and general kind of cloud provider services. And if you need any assistance with anything we've talked about, please don't hesitate to get in touch. Thanks for joining today, and have a nice day.